go ahead and get started here. Happy Friday. I'm ready for the weekend. These 4-day weeks are nice. Alright, so I started grading PA4, and the ones I've graded so far look really good. And, you can tell when you're working on that assignment whether or not it works or not, right? Because you know what it's supposed to do. So, people who are having trouble, for the most part, seem to get in touch with me, and we seem to figure out at least the major details. So a couple of things just based on conversations I had with students this week, and some of the things I've seen, just some things to keep in mind in general about object-oriented programming. One thing is to not go too overboard with making class variables. Okay, a class variable is really global inside the class. So every method that you write inside a class has access to those globals that you declare, in the very beginning of the class definition. And sometimes that makes good sense, right? For example, the array of boxes for this program, we probably want that to be global, right? Because that's something that's going to be used by a bunch of different methods, and we want it to exist outside of those methods. But if you've got, a Boolean variable that you're setting when you find that an edge has been clicked on, or, something that tells you whether or not a box is full, if that's a local variable, if you're only using it inside a method, make it local to that method, okay? One of the reasons being that it can get you into trouble if you think that this is a variable that means one thing, but you're actually also using it in other methods. You can get tripped up by, programming mistakes that would otherwise be caught if you had declared this thing as a local, like not initializing it, for example. Along the same lines, we like to think of data as being like part of an object, right? So, for example, the player's initials, right? One thing you can do is when you're typing in the player's initials, you can be updating a variable somewhere that stores, the player's name, and then any time that name changes, you call a setter in, the paint class to the class with your paint method to update the name of the player, right? And then you've got to remember, like when you hit your reset button, if you're clearing out the players' names, that you have to go ahead and clear it out, using the setter that you defined in the panel class, and so on and so forth. A more natural way to deal with this might be just to take the name from the text field, right? If that text field is part of a JFrame, and if your other objects have access to that JFrame, you can just say JFrame name dot player text field name dot get text and pull the text out of that. And now it doesn't matter, if someone typed it in, if someone pasted it with a Control V or a mouse click, if it's changed 100 times, anytime that you say, that text field name dot get text, you're going to get the current value of that, as opposed to trying to copy that into a local variable or a global variable and keeping that in sync. Okay, so be thinking about that, right? Similarly, finding the score. What is player one's score? Well, we can put that in a variable. We can update it every time that player one completes a box. We can zero it out whenever we reset the game, right? But we could also make a method that would simply go through the two-dimensional array of boxes and count how many boxes have been set to be owned by player one. That's player one's score. And what we're doing is we're minimizing how many things we need to keep in sync with each other, right? If the essence of the game is this two-dimensional array of boxes, let's get our information out of there. And what's nice is we can make a method in, whatever object holds that two-dimensional array. We could make a method called, player one score, and we can just say, object name dot player one score paren, and it will do all of that code for us. Right? But to us, we're just, it's like getting the length of a string. Yeah, it's a method, but we don't really need to worry about it, whether it's a method or a number that's stored somewhere. We just access it, and it's always accurate. So this bundling of data with the objects, with the code that manipulates the data and analyzes the data, that's the mindset of working in an object-oriented language. And so this is my earlier comment about you may want to rework your code as you're developing it and try to stay open to possibly going back and restructuring how you're putting this all together, right? And typically, especially when you're learning a paradigm like object-oriented design, right? It's not uncommon as you start putting some meat on the bones to say, hey, you know what? I think the underlying structure makes more sense if I break it up like this. And you go back and you sort of restructure everything. That's not uncommon, and it's not a bad thing. And since we're reusing PA4 for PA5, right, you have bonus opportunity for going back and rethinking some stuff now that you've gotten to, the other end of PA4. So I'll get the rest of these graded probably tomorrow, Saturday, and I'll leave you feedback. And if you don't have PA4 working to your satisfaction, right, definitely catch me in office hours. And let's work out the last details so that you can go forward with that for PA5 and so on. So any questions or comments or reflections on PA4, or any questions about what we've been doing with networking so far? Alright, let's go on to PA5. So PA5 is a networked version of your DOTS program. Okay, so it's going to be the same gameplay, the same structure, the same board look and feel. Clicking on a mouse to mark lines, complete a box, you get an initial, and so on and so forth. But instead of having two people sharing a mouse, running one instance of this program, you're going to have two people potentially on different machines running your same program, and their mouse clicks are going to be shared, their names are going to be shared, and they're both going to see the same playing field. They're going to take turns clicking their own mouse, and in this way they're going to play dots, okay, across the net. And the way I've structured this and the way I've written this assignment is designed to not require you to go back and rewrite the DOTS program. Okay, as much as possible, I want you to start with what you already have for PA4, right? Tweak it if it's not quite right. And then basically just add one more layer on top of it to handle the networking. Okay, but your code for PA4 already does all of the hard work. It basically responds to mouse clicks. It keeps track of, where you clicked, what line does it correspond to, is that line marked, if not, let's mark it, let's draw it in, if it completes a box, let's give it your initial and keep it your turn, otherwise make it the other player's turn. And all that your code is really getting is mouse clicks, XY coordinates. But it's keeping track of whose turn it is, what the board looks like, and so on and so forth. So theoretically, if you were to have two versions of your program that could just share mouse click information, you could play dots across the web. So we're thinking of it something like this. So this is going to be a client-server model. And you've got your dots field over here. And don't worry about how things get going. That's a separate process. But suppose we're already up and running and we're playing dots. And let's suppose it's the server's move. Okay. And these are just plain old PA4s. Okay. So this is your code that you've already done. So you have a friend and they're running your program and you're running your program and you're talking on the phone. Okay. Or texting or whatever. And you decide you want to click right here. Okay, so you click your mouse right here and it draws this line. and you tell your friend, okay, I just clicked it, X equals this, Y equals that. And what does your friend have to do? Well, they have to go and they have to point their mouse right at that X, Y, and click. And now their board's going to look like your board. And now it's their move. And they're going to say, okay, I'm going to click right here. They'll get this line. They'll call you up and say, hey, I just clicked at 50, 23. And so you'll go click at 50, 23, and your board will draw that line. And your boards are in sync. Okay, and you can play this whole game out. And the only thing you have to do is pass this XY coordinate information back and forth every time that somebody clicks a mouse. So we're going to talk about how to do that. It's going to require you to write a new class. It's going to require us to do some threading, okay, so some multi-process programming. And it's going to require us to make a client-server connection and share information and develop a protocol and do some parsing and things like that. All of which might sound fairly complex, but if we break it down into pieces, each of these steps is pretty minor. Okay, it's really putting them all together in the right way. So let me show you what this looks like, and then we'll go ahead and look at the assignment in full detail. Now you can do this, you can do your testing from Eclipse, okay? But Eclipse is a little tricky trying to run the same program twice at the same time. There's a little console window in the bottom right of your Eclipse IDE, and you can open multiple console windows, one for each instance of your program. And if you make two console windows and you pull them out of your Eclipse frame, that doesn't work too badly, right? But if you use one console window, it switches back and forth whenever one of them makes output, and it's kind of a pain, honestly. So what I'm going to do is I'm going to go into my Eclipse workspace. I'm going to go into my project, which I'm calling net.dot. I'm going to go into the bin area where I have these .class files. And I'm going to make two windows. And I'm just going to say Java net.dot to run it. And I'm going to do the same thing over here. And now I've got two instances of my dots program running. They're both sitting on top of each other, so I'm just going to drag one over here. Okay, so now I've got two programs running. The GUI looks a little different. Okay, I've got this radio button where I can choose, am I the server or am I the client? And my widgets change accordingly. If I'm the client, if I'm the server, I specify my name, because the server is always player 1. Okay, and I have a start button. If I'm the client, I have to specify my name as player 2. I also have to specify the address of the machine running the server. Okay, now I'm doing both of these on my same machine, so I can use localhost, I can use 127.0.0.1, I could use 192.168.0.20, right? But if somebody was running the server on a different machine, right, I could put in the IP address of that machine here. Okay, so server, specify player 1, you have a start button which starts the server running. If you don't specify a player name, it just makes it server. And then client, you can specify the client name, so I'll be Nick, and the host name that you want to connect to, and then you say connect. And you notice as soon as I did that, the server filled in player 2's name, that's Nick, and the client filled in player 1's name, that was server. And both windows are saying it's currently player 1's turn, whose name is server. Okay, so player 2 can't go yet, it's not their turn. Player 1 can click somewhere, and both players see the corresponding edge. Okay, now it's player 2's turn, so player 2 can click here, player 1 can click here, player 2, player 1, player 2, and now server is going to go right here in the middle. and they get 2 boxes. Their score gets updated to 2. Both boxes are filled with their initial, and it's still player 1's turn. And that's exactly what's reflected over here, right? So it's still the server's turn. So server can go right here, and then client and server, and client can go here and complete a box. So now I've got 1 point, and it's my turn again. And then the server can go here, server. All right, so we're playing dots, you know, on the same machine, but this could be a networked connection. It would work exactly the same way. Okay, that's what you're after with PA5, that basic behavior. And then I have a quit button that I can use to close out both windows, and it goes away. All right, so let's start looking at the details. Okay. Dots program, 2 people playing across the network. You can keep using Eclipse. Make sure your code runs standalone, so don't use any special custom classes and such that I wouldn't have available. And basically, this is an extension of PA4, so I haven't told you how to play dots. I haven't told you, you know, about putting in initials and so on. All that stuff from PA4 applies here. Okay. It's still a group project, and you are welcome to either work in the same groups, change groups, decide you're going to work alone, join a group if you worked alone for PA4, whatever you like, okay? The only restriction is, again, groups can be at most 3 people. And, you know, if you're making a change, make sure everybody in the group is aware of it. Don't startle anybody. All right, so specific requirements, okay? First requirement is I want this pair of radio buttons. Okay, so labeled server and client. I don't care where you put them, what they look like, and so on and so forth, but you need a way to specify, am I going to run as the server or as the client? Okay, and use radio buttons for those, so it's one or the other. And the server is always considered player 1, and they go first. Client is always player 2, and they go second. Okay, and I want you to stick to that. And then the look and feel of this GUI changes depending on your identity. If you are the server, you should be able to type in a name in player 1. You should have a button that says start, which will create a server socket. And the player 2 name should be grayed out, so you can't enter anything in there. Okay. If you are the client, right, player 1's name is grayed out. Player 2 can put their name in. You can specify an IP address or a name for the server, and then you have a connect button. Okay, so the GUI looks accordingly. And once you start, right, once you connect or you've created your server socket, your start connect button changes to quit. You do not have to handle restarting the game. You do not have to handle playing a second game after the first game ends. Okay, once you start, you can play as long as you like. You can play until somebody wins. Your only other option is to just quit. So don't worry about restarting, resetting. Okay, that makes things a little easier. And I just found a bug in my code. I don't allow spaces in the person's name. So that's why I typed in me, but the client only saw me. All right, you also don't have to handle errors in connecting. So for example, if the client tries to connect when there's no server running, you can just throw an error, okay? I'm not going to look at your console output. So, you know, if you want to just throw an error or print a message or whatever, that's fine. I'm not going to worry about that. If I, you know, start a server and while the server is running, I try to start a second server, right? I'm going to get an error saying the address is already in use. That's fine. Okay, you can assume when I play your game that I'm going to, you know, play it properly. I'm going to declare a server window. I'm going to start the server. I'm going to declare a client, and I'm going to try to connect. Okay, so after that, game plays as usual. It's just that players are taking turns clicking their own mouse, and everything is kept in sync by communicating through the socket connections. All right. Make sure that you don't let somebody click when it's not their turn. So keep track of whose turn it is. All right. So I have some suggestions on how to set this up. And these suggestions are geared towards, letting you reuse your existing code as much as possible. So first suggestion is we're going to have to do threaded programming. Okay. Remember, when you're inside your mouse handler, when you're inside your paint method, you're basically processing an interrupt. So you can do whatever you need to do in response to that event, but you can't do things like go into an infinite loop or wait for user input or things like that. Okay? It will totally hang your GUI. If you were to resize it at that point, it would get all wonky looking. So we're going to need to receive messages from the other person through a socket. That's a blocking operation, right? We're going to say, while sc.hasNextLine, string buffer equals sc.nextLine, right? We don't want to do that inside the mouse listener. We don't want to do it inside the paint method. So we're going to make a new thread, a separate process that will handle that communication and then take what it's received and share that with the other objects in our game. Okay, so we won't get to threaded programming today. We'll talk about it a lot next week, but I will post a video tomorrow that introduces you to threading in Java, and it's the simplest version of threading that we're going to need to use. We're not going to have to worry about all of the complexities that we'll go into next week. So I'll post a video if you want to get jumping on this weekend. So my suggestion here is make a separate thread. I'm calling it net thread in here. You can call it whatever you like. And in the very beginning, start that thread, let it set up the communication with the other player, and pass all information that you need to share using that process. Okay, the two games should automatically stay in sync, right? They're going to move and update in lockstep. Right? If it's the client's turn, the client knows it's their turn, the server knows it's the client's turn, right? If the server user clicks right here, it should say, hey, it's not your turn, right? Or it should notice that. If the client makes a click, right, it should draw a line because it knows its turn. It should send to the server the fact that the user clicked at a particular XY, which your server code will say, oh, there's a line. No box got completed. Now it's the other player's turn. And they'll both do the same processing. They run the same code. They both say, oh, now it's the server's turn, right? And now, your displays are in sync, your games are in sync, and there's a uniform notion of whose turn it is. So you don't really have to work hard to keep things in sync. Okay, it should just happen as long as you start things off correctly. So if it's your turn, basically at some point you're going to click the mouse, which brings you into your mouse listener, and your code will, confirm that it's your turn. It will update some sort of data structure, right? So your array of boxes, it'll go through and it'll set in Boolean to be true. And then it calls repaint. The only other thing you have to do is send the XY coordinates of your click to the other player. The other player knows it's not their turn, so they're ignoring mouse clicks. But their net thread process will receive this message saying, hey, the other player clicked at this XY coordinate. All you've got to do is run your code that would run if the other person had physically taken your mouse and clicked it, right? So what does this look like? Let's look at your mouse listener. So your mouse listener gets, called with an argument 0, a mouse event, and x equals arg0 get x, and y equals arg0 get y. If not my turn, do something. But don't do anything with the mouse click, right? So you might do this before you get the X and Y, right? So you're in your mouse listener. Check to see if it's your turn. If it's not your turn, don't continue processing the mouse event. Okay, the person clicked while they weren't supposed to. So ignore them. Okay. Otherwise, what do you do? Otherwise, you respond to your mouse click. So, find row and column, find the nearest edge, check the Boolean, set the Boolean if it's not already marked, repaint, update scores, etc., etc. Okay, so in some way, shape, or form, this is probably what your mouse click code looks like. Okay, specifics will vary, but basically when you get a mouse click, you're going to check to see if what the XY coordinates are. You're not doing this check to see if it's my turn right now because, it's always somebody's turn. But you're using those XYs to find the row and column, find the edge, and so on and so forth. Okay, so here's what you do. Move all of this stuff into a separate method. So handle click x comma y, for example. Okay. So now your mouse listener says, okay, if it's not my turn, just get out of here. Find the XY coordinates. Call my handle click code. So do all of this stuff that you're already doing, right, in this separate method. So pass the XY coordinates to this. It'll go ahead and figure out the row column with the nearest edges, check the proper Boolean and the proper element in your array of boxes, and so on and so forth. Okay, and then call a method send to other player x comma y and get out of there. So your old version probably looked something like this. Find the XY coordinates, figure out row, column, etc., etc. Okay, now find the XY coordinates, make sure it's your turn. If it is, call this code, and then send the XY coordinates to the other player. And this is just a method in your thread class that basically makes a string and pushes it out through the socket. Okay, it's a printWriter.println. And then you also have this process that's running, which is going to be called run. And the whole thing this does is read from the other player. So, set up your scanner to read from the socket. While there's another line available from the scanner, right? Read in the next line. Parse that line into a pair of XY coordinates, right? because when the other player says send to other player XY, it's going to make a string containing the X and Y coordinates. It's going to send those to you. You're going to get that when you say scanner.nextLine. Break it up. Okay, we'll talk about how to do that, but it's a simple parsing operation. And then call your handle click code. And what does handle click do? Well, it does what you do when somebody clicks at XY. It figures out the row and column, the nearest edge, checks the booleans, etc., etc. So you don't have to change most of your code, okay? Once it's playing, basically all you have to do is in your mouse listener, send the coordinates to the other player, right? Make sure that it's the player's turn before they click. And you can do that later. You can just assume the person's not going to click at the wrong time. Send the coordinates to the other player. Do your usual handle click code. And in the separate thread, every time you read a message from the other player, parse it into XY coordinates, run that same code that was inside your mouse click listener. Alright, so there's two things that run your mouse code. Either a mouse click itself or the receipt of a message from the other player, which you read and you parse and you call your mouse click code. Alright, the other thing you have to do is you have to get this whole process set up. So you're going to have to write some new code for what to do when the start button is clicked. Okay, to create this initial communication. But that's it, really. Two changes primarily to the gameplay. One is an initialization, the other is picking up these messages. Alright, so what do you have to share between your process and the other process? Player names. You need to introduce yourselves to each other in the beginning so that you can display the other person's name on your GUI. XY coordinates and mouse clicks, and maybe a quit message. Okay, I've decided I think the quit message is optional because I think if you just close everything out and close all your sockets, the other process will go away. Okay, but if you want to be clean about it, have a quit message also. So here's a simple protocol that works well. As soon as you establish a connection, send your name to the other player, and then read one line of input from the other player. The line that you read, treat that as the other player's name. The other player is running the exact same code. They're going to do exactly the same. Once they connect you, they're going to send you their name, and then they're going to read your name. Okay? And it doesn't matter if you're both sending first and then both receiving, right? This stuff is all buffered and managed for you. So each side, just send your name, read a line, take what you read as the other player's name. Okay, in my version I use a slightly different protocol, but this seems like a simplified protocol. This should work well. When you want to send XY coordinates, here's an idea. Send a message that starts with an uppercase C followed by a space, the X coordinate followed by a space, and the Y coordinate. Okay, and when your receiving process receives a message, see if the first character is a C. And if it is, parse it out into two things separated by spaces, and then convert each of those to an actual int. Okay, so look at the split method in the string class. That's a useful way to break up a string into pieces separated by spaces. Okay, and then once you have a string containing an integer, right, you can use integer.parseInt, uppercase I here, to convert that string into an actual integer. And then I said a message that begins with a Q is considered a quit message, and when you receive that, just close everything down and exit. All right, so these suggestions, again, will basically let you extend PA4, right, without having to do a whole lot of rework. If you stick to this protocol exactly, you'll be able to play with anybody else who is also stuck to this protocol exactly. Okay, but for development, for debugging, and for grading, what I'm going to do is I'm going to take your program and I'm going to run it twice. And one instance I'm going to say I'm the server, the other one I'm going to say I'm the client. And then I'm going to have them talk to each other and play the game together. Okay, so your code does not have to work with anybody else's code. It just has to work with itself. Okay, so that's this here. Comment about working in Eclipse versus the command line. One thing that works really well is developing in Eclipse, right? Because you can do auto completion and it'll do imports for you and so on. But if you drop into a terminal window in the bin area of your workspace, right? Anytime you save your files, they get automatically compiled. So you're writing code, all you got to do is hit Control S, and you can pop into here and rerun the latest version of your code and start debugging. Okay, and that's going to probably be a lot faster than monkeying around with the console windows and such. Okay, but it's up to you. Whatever makes sense, but spend a little while figuring out how to do this efficiently. Okay, whatever works most efficiently for you, go with that. All right, grading, pretty straightforward rubric. So if I can download and compile all of your code, 15 points. If running your code draws a GUI, has those 2 radio buttons, and has some text fields and such, that's 15 more points. If the radio buttons actually change between client and server, as in updating the GUI the way it's described above, that's 10 points. And if clicking the start button on the server and the connect button on the client actually creates a connection between the two, a network connection, right, that's another 10 points. After that, they should swap names with one another and they should display each other's name on the GUI. If that works, that's another 10 points. And then if clicking a mouse does the right thing, right, draws a line on both GUIs, completes a box. If a box is completed, fills in an initial, manages whose turn it is, updates the score, and all of that stuff. If that works correctly between the two, that's another 20 points. Okay, if it blocks out of turn mouse clicks, that's another 10 points. Again, you can handle that at the very end. It's really just a Boolean flag, right? Just alternately set it, and if the Boolean says it's not your turn, ignore mouse clicks. Then if the quit button exists and exits both sides, that's your final 10 points. Okay, and I really want to emphasize there's a lot going on, right? When I click on my board, I might draw a line, complete 2 boxes, put my initial in both of those, update my score by adding 2 to it, and still indicate that it's my turn. You do not need to send all that information to the other process. Okay? All you got to do is send the XY coordinates of the click and let the code on the receiving side do all of that work. If you try to come up with a complex protocol where you send the entire board array, or you send the score or things like that, you're doing a whole lot of work and you're missing sort of the elegance of having these things stay in sync. Okay, so just send XY coordinates. Submission, main class should be called net dot, no S at the end. GitLab repo is CSE223 net dot. Use the default package, upload to GitLab, make me a reporter, and you're good to go. So let me just show you. I don't think I said it, but you're communicating on port 1234. Okay, so the connect button. Yeah, so let me go through this for the server. Start button creates a server socket. Okay, listening for connections on port 1234. For the client, right, when you hit the connect button, it should look at the name in the host ID and then create a socket using that host ID and using port 1234. Okay, once this is done, we still have to go through an example of creating the client side in Java. But once this is done, both programs, they just have a socket. And they'll create a scanner for reading from it, they'll create a print writer for writing to it. And from that point on, it makes no difference who is the client and who is the server. Okay, the networked part, the only difference is, who creates a server socket, who creates a socket. But once that's done, they're both reading to and writing from sockets through print writers and scanners. Okay. So let me show you an example. So I've got a server over here. I'll call this Nick, and I'll start the server. Let me, instead of running the program again as a client, let me just use telnet. So I'll telnet to localhost, that's this machine, and I'll go to port 1234. And we can see what the server is doing and how the server responds. This is a useful way to debug your code while you're developing it. Okay, so I use a slightly different protocol. When I first get a connection, I send out a message that starts with the letter N, followed by a space, followed by the name. Okay, so as the client over here, I just got a message saying, hey, the server is being run by someone named Nick. Okay, and I would update my name accordingly. And now the server is waiting for me to say who I am. Okay, so I'm going to say N Billy. Okay, and now the server has been told my name is Billy, and it's filled that in under player 2. And now the game is playing. Okay, and it's player 1's turn, because the server is always player 1, they go first. So let's suppose I click over here. Okay. So my code's running as usual. It saw the click, it figured out the row column closest edge, set the boolean, called the paint method, drew the line, but then it also sent a message to the client. Okay. Now I suggested that you just send, a letter C followed by XY coordinates. Like this. And that's probably the easiest thing to do. But when I wrote this, I did something different. I send a pair of messages, one for X, one for Y. Okay, so I can see that the client told me the person clicked it, X is 102, Y is 72. And I would, run that through my mouse click code to draw the line and update the data structure and so on and so forth. And then I flip a flag which says, okay, now it's my turn, so I wait until the mouse listener runs, and when the mouse listener runs, it'll say, oh, you just clicked at 155 comma 29, right? So I'll say let's send a message saying X was 155 and Y was 29, and when the server gets that message, what does it do? It draws a line. Right, and no box was completed, so now it's Nick's turn again. So here's Nick, and now I know that Nick just clicked at 120 and 7, and I could say, okay, well, I'm going to click at 120 and 57. Right, so I'm taking that top. So this is all that's being shared, right? And like I say, if you do it in this way, it's just a single line message. Just say, coordinates X, Y. So you can come up with your own protocol if you like. A couple of suggestions there. And if I'm done, I can say quit, and server received quit, and close down. So you can use telnet to help you debug, okay, which is nice. So questions about that? It's quite a bit of detail, but as always with these things, hopefully if you approach it in pieces, the pieces themselves aren't too overwhelming. Alright, so I will get things graded sometime tomorrow probably. I will post a video on Threads and threaded programming because we need the network connections to happen in a separate thread. I'll probably post a quick video on making the client side connections with a socket, but it's really straightforward. Just construct a socket with host name, comma, port number. And once it connects, you can just, make a scanner, make a print writer, and talk through the socket. All right, I don't have to make a video. There's all you need to know. But we'll talk about that. We'll go through some sample code next week. And we'll spend most of next week talking about networking, or threading, right? And some of the details. Like I say, the threading you have to do for this is pretty straightforward. It won't deal with a lot of the issues that we'll talk about next week with deadlock and live lock and synchronization and volatiles and all that sort of stuff. All right. Any parting questions, comments, concerns, predictions? 78 degrees and sunny outside, so hopefully you can enjoy the rest of the afternoon. I will have office hours from 3 to 4. If I don't see you then, have a great weekend, and I will see you next time.